Hello everyone. Today topic is BSc first year topic, that is paper name is Mechanics of a Particle. So that is semester 1 paper. Today is discuss about the linear momentum of a particle. What is the linear momentum and conservation of linear momentum and collisions and impact parameter and scattering cross sections. Okay, now we discuss before you can discuss in Newton's laws of a motions. So Newton's laws of a motion, three laws of this motions of classical mechanics that are describing the relation between the motion of an object and the force acting on it. So then any body is motion, then we applying the force, then force is applying, then body is momentum. Now no forcing applying, that is no motion. So that is discussing about motion and forces related. So this is motions, Newton's laws. Newton's laws are three types. This is Newton's first law and second law and third law. First we have discussed Newton's first law. This law is also law of inertia. So first law is what is the first law? States that a body at rest or uniform motions will continue to be at a rest or uniform motion until or and unless a net external force acting on it. Suppose, let an example, this is the resting position at a ball. Ball is no force applying, then it is ball is at a rest position. So applying in force, then ball moves only when a force is applied in the motion. So uniformly motion. So what is the first Newton's law? It means బాల్ అనేది మనం ఫోర్స్ అప్లై చేయనంత వరకు ఆ బాల్ అనేది రెస్ట్ పొజిషన్లో ఉంటుంది. సో సమ్ అప్లై ద ఫోర్స్, దెన్ వి మూవ్ టు ద మోషన్ టు ద బాల్. సో మనం రెస్ట్ పొజిషన్లో ఉన్న వస్తువును రెస్ట్ పొజిషన్లోనే ఉంటుంది. సో కొంత ఫోర్స్ అప్లై చేసినట్లయితే ఆ ఫోర్స్ వల్ల అది మోషన్ అనేది ముందుకు జరగడం జరుగుతుంది. సో అలాంటి దాన్ని న్యూటన్స్ ఫస్ట్ లా ఈజ్ అప్లికబుల్. What is the Newton first law? States the body at rest or uniform motion will continues to be a rest or uniform motion until and unless a net external force acting on it. So suppose manam any hand. So suppose let us consider one example, that is table. Table is in rest position. Then applying the force, then the motion, that is the move one place to another place. So will force is applying continuously, that motion moving to the table is one place to another one. So that is the uniform motion, that is and until and unless a net external force acting on it. That is the Newton's first law. And what is next? Newton's second law. The rate of change of the momentum of a particle is directly proportional to the net external force and take place in the direction of the force, that is F proportional to dp by dt. The rate of change of momentum of a particle, that is dp by dt. So is directly proportional to the F. So that is F proportional to force, that is F means force, and P is the linear momentum. So that is the rate of change of the angular momentum, that is dp by dt. So that is force is proportional to dp by dt. So F proportional to what is the momentum? Momentum is equal to, that is mass and velocity, the product of the mass and velocity, that is P is equal to mv. F proportional to d by dt of P is equal to mv. So F is equal to k into m into dv by dt. So that is m is the mass and dv by dt. So k is the constant value. The time rate change of the velocity of a body is termed as its acceleration. So acceleration means that is velocity by time, that is a is equal to dv by dt. So therefore that is then applying acceleration in dv by dt, that is therefore the force is equal to k into ma. So here the this is the unit of the force are also chosen such that k is equal to 1. The result of a unit force is selected to be the force causing a unit acceleration in a unit mass, that is F is equal to 1 Newton and m is equal to 1 kgs and a is equal to 1 meters per second square. This implies that is k is equal to 1. So k is equal to 1, you can apply the F is equal to k into ma. So k is equal to 1, then therefore that is F is equal to ma. The Newton's second law of motion is mathematically is representing F is equal to ma. This is the Newton's second law. And one example is, if F is equal to 0 and then acceleration is also 0. So then apply to Newton's first law. So force is equal to 0 అంటే means that is rest. ఫోర్స్ అనేది వన్ బాడీ మీద అప్లై చేయనట్లయితే ఆ వస్తువు అనేది రెస్ట్ పొజిషన్లో ఉంటుంది. దెన్ అప్లయింగ్ సమ్ ఫోర్స్ రెస్ట్ పొజిషన్లో ఉన్నట్లయితే దట్ ఈస్ ద వెలాసిటీ ఈజ్ ఆల్సో 0. సో యాక్సిలరేషన్ ఈజ్ ఈక్వల్ టు 0. సో దట్ ఈస్ అప్లై టు న్యూటన్స్ సెకండ్ లా ఇన్ apply to the Newton's first law. So that is this is no net external force, there will be a no change in state of the motion. This is implies to the acceleration is also 0. That is the Newton's first law is applicable to the second law is also. So one example of Newton's second law is that is pushing a trolley and pulling the cart by applying the force. But what happen if there is net force is acting on a body? So Newton's prescribe the velocity of a body is increasing or decreased by applying a net force. If the net force is applied to the sideway of an object, its direction of the velocity will change, which is called the acceleration. This is called as Newton's second law. Here example, so then applying the force, some force is applying, this is mass and force is applying. This boy is applying to this item, that is the some speed of increasing. So more force is applying, then more acceleration is more. So that is direction is will also change. Then the net force is applied to the sideway of this object. Its direction of velocity will change. It is called as acceleration. That is this is called the Newton's second law of example of this is. So another one, third law, Newton's third law. Newton's third law states that for every action there is always an equal and opposite reaction. So what is the Newton's third law? Every action there is always an equal and opposite reaction. So let us consider two bodies, that is body A and body B. Then let us assuming FAB F is a force of a body acting on B, and FBA is forced by a B on a body A. The mathematically can be expressed is FAB is equal to, that is FAB is equal minus FBA. So what negative sign? The negative sign indicating is apply the force acting a body is in opposite directions to the force which acts on a body is B. So that is the FAB is an action on B, while FBA is an action of A. So that is action and reaction. So that is the mathematically then express is FAB is equal to minus FBA. So best example is motion of the rocket, and another one when releasing a air filled balloon, the force of the air coming out of the balloon in the action on which are equal and opposite force on the balloon is called reaction by moving upward direction. So same as it is also motion of a rocket is also then applying the force, then air is నాజిల్ గుండా బయటికి ఎయిర్ అనేది వస్తుంది, దెన్ ఆపోజిట్ డైరెక్షన్లో రాకెట్ అనేది మూవింగ్ అప్వర్డ్ డైరెక్షన్లో మూవ్ అవ్వడం జరుగుతుంది. దట్ ఈస్ అనదర్ వన్ ఆఫ్ ది ఎగ్జాంపుల్ ఆఫ్ మోషన్ ఆఫ్ ఏ రాకెట్ ఆల్సో. అండ్ ఎయిర్ బెలూన్ ఫిల్డ్ చేసుకున్నప్పుడు దట్ ఈస్ ఫోర్స్ అప్లై చేసుకున్నట్లయితే మనకి కమింగ్ అవుట్ ఆఫ్ ద ఎయిర్ బెలూన్ ఇన్ దిస్ యాక్షన్, అండ్ అపోజిట్ ఫోర్స్ ఈజ్ ఆన్ ది బెలూన్ ఈజ్ reaction by moving upward direction. That is also called the Newton's third law is example. These are the Newton's first law and second law and third law. Okay. Then another one, that is linear momentum of a particle. What is the linear momentum? Linear momentum is defined as the product of the mass and velocity of the here P is equal to m dot v. This is the linear momentum formula. P is equal to mv. Linear momentum is a vector quantity also, and linear momentum of a system of a particle. Let us consider a system of n number of particles having mass 1, mass 2, mass 3 up to mass n particles. Particle that is the nth particle mass is mn with velocities v1, v2, v3 up to nth velocity is the vn. Then the linear momentum of the system in a particle, reference frame is the vector sum of the momentum of individual particle. So, that is p is equal to p1 plus p2 plus up to pn. That is therefore, p is equal to m1 v1 plus m2 v2 plus m3 v3 up to mn vn. This is so p is equal, you can write summation of I equal 1 to n. So, 1 to n particle number of particles, that is m 1 and v1. So, you can write summation of I equal to 1 to n, that is capital M into v, that is Cm. So, velocity of the center of mass, Vcm means velocity of the center of mass, m is the mass, total mass, that is p is equal to m into Vcm. This is velocity of the center of the mass of the system. So, that is the total linear momentum of a system of particle is equal to the product of the total mass of the system and velocity of its center of mass, that is called the linear momentum of a particle. So, next conservation of a linear momentum. What is the conservation of linear momentum? The states that the vector sum of a external force acting on a system of a particle is 0. The total linear momentum of the system remains constant, that is p is equal to m into Vcm. So, that is m is the total mass and Vcm is the velocity of the center of mass of the system. So, this equation, momentum equation is differentiating in this equation. So, dp by dt is equal to m into dv by dt. This is differentiating with respect to the momentum formula, that is dp by dt is equal to m into dv by dt. dv by dt is the acceleration of the center of the mass. So, therefore, dp by dt is equal to m into a, that is acceleration, that is velocity by time. So, you can write dv by dt is equal to a. So, and a is the acceleration of the center of mass and ma is the external force, then dp by dt is equal to f external force, that is ma is the external force is applying, that is f is equal to dp by dt is equal to f external. This is the external force. Okay, you can write ma is equal to external force. So, that is f external is equal to ma. The rate of change of the momentum of a system of a particle is equal to the vector sum of all external force acting on the system, provided no mass leaves or enter the system. Where when no external force acting on the system, that is f external is equal to 0, that is dp by dt is also 0. So, dp by the rate of change of the momentum, that is equal to 0. So, that is p is equal to constant. This is the linear momentum of the, that is conservation of linear momentum is equal to constant. That is, you can write p is equal what? Number of particles, that is p1 plus p2 plus up to pn, that is equal to also constants. When the external force on a particle system is equal to 0, the system's total linear momentum is constant. So, this is the proof of the law of conservation linear momentum. Okay. So, this is the what is the linear momentum, that is p is the product of mass and velocity, that is p is equal to mv. So, this is different, that is number of particles, you can n number of particles having the number of masses and number of velocities. The linear momentum of the systems in a particle reference frame in the vector sum of the momentum of individual particles, that is p is equal to m1 v1 plus m2 v2 plus dash dash up to mn vn. You can write, that is summation of I equal 1 to n m1 v1. So, you can write m into Vcm, that is m is the total mass and Vcm is the center of the mass of the velocity. Okay. This is the this you can write p is equal to mvc, then differentiating with respect to t, you can derive this dp by dt is equal to m into a, that is a is the acceleration of the center of mass, a is equal to dv by dt. So, you can write dp by dt is equal to MA. So, MA is the external force applying, that is F external is equal to MA. So, dP by dt is equal to external force, that is F external. The rate of change of the momentum of the system of a particle is equal to the vector sum of all external force acting on the system, providing no mass leaves or entire this systems. So, no external force acting on this system, that is F external is equal to 0, that is dP by dt equal to 0, that is P is equal to constant value. This is the total number of particle, P is equal to P1 plus P2 plus P3 up to Pn is equal to constant. There is no external force, that is the particle system is equal to 0. This is the total linear momentum is constant. This is the theorem, this proves the law of conservation of the linear momentum. And next topic is collisions. What is the collision? You know everyone, a collision happens when two bodies coming in direct contact with each other. In the case of the two bodies of exert force on each others in a short period of time. So, any two bodies is then this is any two bodies come into direct contact in each other, that is the body is exerts force on each other in a short period of time. These are collisions are two types, elastic collisions and another one in inelastic collisions. Elastic collision means an elastic collision is the collision in which there is no net loss in kinetic energy in the system due to the collision. Both momentum and kinetic energy are conserved in an elastic collisions. So, elastic collision is the net loss in kinetic energy in the system due to this collision. Both and momentum and kinetic energy is applied to the elastic collisions. Okay. Elastic collisions is the example is when a ball at a billiard table hit another ball. So, you know tennis ball, then ఆ బాల్లో మనం ఒక బాల్ని హిట్ చేసినట్లయితే అనదర్ బాల్కి టచ్ అవుతుంది, దట్ ఈస్ ద కొలిషన్స్. సో దట్ ఈస్ ఎగ్జాంపుల్ ఆఫ్ ద ఎలాస్టిక్ కొలిషన్స్ ఆల్సో. So, when you know a ball on the ground and it is bounce back to your hand, there is no net change in the kinetic energy and hence it is an elastic collisions also. So, what is the elastic collisions? Elastic collisions is applicable to the momentum and kinetic energy. So, elastic collisions is formula of momentum is that is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So, what is the m1 m2? That is the mass of the particle. Any two particles that is mass is m1 and m2, that is the initial velocity is u1 and u2, and after collisions the mass of m1 and m2 mass after collision, that is the velocity is the v1 and v2. So, that is you can write conservation of momentum is given by m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 is applicable the elastic collision formula of. And another one is elastic collisions is momentum and kinetic energy is also applicable. So, that is what is the kinetic energy is formula of mv square. You can apply any two bodies of the mass, any two particle is mass m1 and m2, that is the initial velocity is the u1 and u2, and after collision the body two particle velocities is v1 and v2. You can write applying the kinetic energy, that is of m1 u1 square plus of m2 u2 square is equal to of m1 v1 square plus of m2 v2 square. This is the elastic collisions formula in kinetic energy. Okay. And another one is inelastic collisions. The collisions in which the momentum of the systems is conserved and kinetic energy is not conserved are the inelastic collision. Only applied to the momentum and no kinetic energy is not conserved this collisions. Okay, this collisions is which the momentum of this system is conserved, only applicable to the conservation of momentum is applicable, and kinetic energy is not conserved in this law. So, what is the examples of inelastic collision? The collisions between vehicles such as bushes, car and trucks, etc. These are all collisions are inelastic collisions. What is the formula of inelastic collision? Only inelastic collisions is applicable to the momentum of the systems. So, that is why when we can write, when two object collides under the inelastic condition, the final velocity with which the object moves is given by v is equal to m1 v1 plus m2 v2 by m1 plus m2. That is the formula of the inelastic collision is applicable of the velocity formula. Final velocity v is equal to m1 v1 plus m2 v2 by m1 plus m2. Okay, this is the inelastic collisions. And next one is impact parameter. So, what is the impact parameter? Impact parameter is a, let us consider a positive particle. This is positive particle is positive particle like a proton or a alpha particle. Then this is alpha particle or proton. The proton is approaching in straight line, and that is nucleus is ikkadunna alpha particle gaani, this is proton gaani, these are both are positive particles. So, this is alpha particle is reach in nucleus. So, both are alpha particle and here positive particle, these are both, this is here also alpha particle is positive and nucleus is positive, this particle is both are collisions. So, due to the Coulombic law that is repulsive force is applying, then hyperbolic path is here hyperbolic path అనేది ఏర్పడుతుంది, that is A to B is hyperbolic path. So, let us, nucleus means alpha particle and that is positive particles, proton or neutrons, nucleus is equal to protons or neutrons. Then here nucleus is the positive particle, that is proton, and alpha particle are also. So, here alpha particle is passing through the straight line, then this alpha particle in reach to the nucleus, then these are both are positive particles, that is applied to Coulomb's law in repulsive force, that is దాని వల్ల మనకి ఎలా ఏర్పడుతుంది, that is hyperbolic shape అనేది AB path అనేది hyperbolic path అనేది ఏర్పడడం జరుగుతుంది. సో, అదర్వైజ్ ఒకవేళ ఆల్ఫా పార్టికల్ అనేది ఈ స్ట్రేట్ లైన్లోనే మూవ్ అవుతుందంటే, అంటే ఆల్ఫా పార్టికల్ అనేది న్యూక్లియస్ అని రీచ్ కాకపోతే అది ఓన్లీ స్ట్రేట్ లైన్లోనే ఫాలో అవ్వడం జరుగుతుంది. సో, ఈ స్ట్రేట్ లైన్లో ఫాలో అవుతున్నప్పుడు మనకి దెన్ ఇది రిపల్సివ్ ఫోర్స్ అనేది అప్లై చేయనట్లయితే, దట్ ఈస్ ఒక పర్పెండిక్యులర్ లైన్ అనేది, నార్మల్ లైన్ అనేది ఫామ్ చేయడం జరుగుతుంది. దట్ ఈస్ దిస్ ఈస్ NM, NM ఈజ్ ఈక్వల్ టు ఏంటి, దట్ ఈస్ P, దట్ ఈస్ కాల్డ్ the distance is called the impact parameter. It is also called that is collision parameter also. Okay, this alpha particle then reach to the nucleus, these are both are collisions, then Coulomb's law is repulsive force, that is then we can find these are both are collisions, then apply to the repulsive force, Coulomb's law for repulsive force, then this is hyperbolic path, that is AB path is form avutundi. So, otherwise alpha particle is not reached, then this is the straight line is then passing, that is this is the perpendicular draw the NM, that is the distance of P is equal, the distance of NM is equal P is called the impact parameter. This is also called collision parameter is also. This is the impact parameter. And another one is scattering cross section. This is the scattering cross section is the that is symbol of sigma, the ratio of number of scattering particles into solid angle, that is dW for unit time to the incident intensity. This is the incident beam that is the incident beam is the n number of particles, that is incident, then this is approaching, then scattering of this number of particles, that is number of particles is dn. So, that is angle of dw. So, for unit time to the incident angle, that is theta. So, that is the called scattering cross sections. What is the scattering cross section? Sigma is equal to dn by n. What is the dn? That is the number of particles. So, number of particle in within a solid angle dw for unit time to the incident intensity, that is called the scattering cross section. Sigma is equal to dn by n. This is the scattering cross section. So, once again I can repeat impact parameter and scattering cross section. Impact parameter, let us consider a positive particle like a proton or alpha particle approaching a then nucleus, that is n, that is the distance of nm is equal to is called the impact parameter. It is also called collision parameters, that is the impact parameter. And scattering cross section is sigma is equal to dn by n, that is the number of particles into solid angles dw for unit time to the incident of the intensity, that is called the scattering cross section. Okay. This is the conservation of linear momentum and collisions and impact parameter and scattering cross sections. Thank you everyone.